Hey everyone, it's Miss B, and in this video we are looking at Unit 4, Lesson 7 of the Illustrative Math Algebra 1. So the first thing we're looking at here is question 1, and this is a graph, and we're going to actually decide some things about the different intervals on this graph. So it says the temperature was recorded at several times during the day. Function T gives the temperature in degrees Fahrenheit, n hours since midnight. Here's the graph of the function. For each time interval, decide if the average rate of change is positive, negative, or zero. So let's dig in from 1 to 5. So these are all n values, which means they are our input because n was our time of day or hours since midnight. So from 1 to 5, from 1 to 5 definitely looks like this is decreasing or going downwards. That is negative average rate of change. So we would say this is negative. You may also call this decreasing, but they asked us to use positive, negative, or zero. So from 5 to 7, this is where things get a little tricky. 5 is here, and 7 is here. Now, these look like they could be pretty even, but I'm going to say that this dot at 7 is actually above the other one. So overall, it's a very slight increase, but I'm still going to say that it's positive. So we'll say this is positive. Okay, from 10 to 20. So we find 10, go find our dot here, and then at 20, and find our dot here. Really, we're going to just kind of look at our starting and end point, even though this increases and then decreases, the average rate of change just goes from the start to the end. And so that is definitely going upwards. It's increasing, so this is positive as well. And what's our next set of numbers? From 15 to 18. Okay, so we have 15, 16, 17, 18. So this number down here at the bottom is 15, which means I'm following this line. So I have 15, 16, 17, 18. And it does actually look like 15 and 18 are measured at the same number. So I am going to say that since there is no change between those two numbers, we will say this is 0. So even though our value changed a little bit in between, it wiggled up and down a little bit, we're only looking at the values for 15 and for 18. So there was 0 is our average rate of change. And then our last set is from 20 to 24. So let's look over here, 20 to 24. 20 puts us right here, and 20 to 24 follows this line here. So I can see that it's decreasing. 20 to 24 is definitely going to be negative. And that's it for that question. Let's look at our next one. For question 2, the graph shows total distance in feet walked by a person as a function of time. So was the person walking faster between 20 and 40 seconds or between 80 and 100? So let's analyze those pieces first. Between 20 and 40. So if we look at 20 and 40, that means we are just looking, whoops, let's zoom in. I didn't mean to do that. So we're just looking right here between 20 and 40. And how steep this line is going to change how fast that person is walking. So we don't have much of an incline here, but they're still walking there at a decent pace. But they wanted us to compare that to between 80 and 100. And between 80 and 100, they definitely covered a lot more ground, and it looks like they have a much higher rate of change. So we would say the person was walking faster. Walking faster between 80 to 100 seconds. Now they're asking, were they walking faster between 0 and 40 or between 40 and 100. So let's look at 0 to 40. 0 would be our start and 40 right here. So 0 to 40. That looks like, if we're kind of counting almost our slope here, up 1 over 1, up 1 over 1, we have about that same thing. Or between 40 and 100, we're going at a slower pace, it looks like, because I have to go up 2 and then over 3. So it's not quite going to be the same. I'm not going up the same number as I am going over, which means, well, even if we just compared it, that line versus this line, there's definitely a bend downwards. It doesn't continue straight. If it continued straight, we would be something like here, up above. So we'll just say they were walking faster. And that is between 0 to 40 seconds. All right, there we go. Question 3. The height of a squirrel running up and down a tree is a function of time in seconds. So the height in feet is a function of time, which means this is our output and this is our input. Here are statements describing the squirrel's movement during 4 intervals of time. Match each description with a statement about the average rate of change of the function for that interval. So instead of looking at a graph, we're now looking at descriptions and going to imagine what we see on a graph there. So this is the height of the squirrel running up and down the tree. So if the squirrel runs up and down the tree very fast, that's our first option. That is going to be positive because the squirrel's height is going to be increasing. So it's not going to be negative. It's not going to be 0. It's not going to be small and positive. It's actually going to be large because the very fast is what's going to make this large. So I'm going to use red, I guess. Squirrel runs up the tree very fast. I'm going to say that is our very positive large rate of change. Okay, now if the squirrel, for this next one, the squirrel starts and ends at the same height, then the average rate of change is nothing. Even though the squirrel's moving in between, the average rate of change is 0. And so this one just goes with the one right across from it. The average rate of change is 0. If the squirrel runs down the tree, that is going to give us a rate of change that is negative. So we are going to have a negative value here. And then we want to make sure that D matches up, running up the tree slowly, that matches with slow or small and positive. And it does. So that's it for our first page. Let's look on the next side of this paper. Question 4. The percent of voters between ages 18 and 29 that participated in the United States presidential election between the years 1988 to 2016 are shown in the table. The function P gives the percent of voters 18 to 29 years old that participated in election year T. Determine the average rate of change for P between 1992 and 2000. So they're saying the year is T, and that our function P just gives the percent of voters. So we're going to try to determine our average rate of change between 1992 and 2000. So we have to look at these two values on our table. So 1992 and 2000. So this is just like doing slope, and I'm going to demonstrate the method I like to use for doing slope, but I'm going to write these as ordered pairs. So I'm going to write out first that I have 1992 as my input, and my output is 42.7. And then I'm going to write out 2000 and 34.5. Now, while you can do the y2 minus y1 equals x2, or not equals, y2 minus y1 over x2 minus x1, I prefer to just sort of stack these up. So what I'm going to do is take this entire thing, and I'm going to write it underneath here. So this is 1992 and 42.7. And what I'm going to do here is I'm going to make this entire thing a subtraction problem. And I'm going to remember that here for my first one is my inputs and my outputs on the second one. Because our average rate of change is going to be those things subtracted, and then we're going to have to do output over our input. So let's actually do our subtraction. I'll zoom in on the work here a little bit. We're going to do 2000 minus 1992. So first off, that is going to give us 8. And then 34.5 minus 42.7. Now that's going to give us a negative number. Let's do 34.5. I'm plugging this in a calculator just so I don't mess it up. Plus, I'm already messing it up, minus 42.7. Here we go. Okay, so now this gives us negative 8.2. So those are our differences between them. But now we have to take these numbers and put it in this format. So our average rate of change here is going to be negative 8.2 over 8. And that is actually what we're going to simplify. So negative 8.2 divided by 8. And that is the same as negative 41 over 40, or I'm just going to write it as a negative 1.025. And that is our average rate of change. It's decreasing, or it's negative. Pick two different values of t so that the function has a negative average rate of change between the two values, and then determine the average rate of change. All right, so we want to pick starting and ending numbers just like A. So we want to be moving forward in time, but we want our percentage of voters to change and decrease. So let's actually look up at our table here and see what we can find. We can actually even go from 1996 to 1988. So I know that this is moving forward in time, but it's moving down in value. That means we're going to have negative rate of change, but I am going to leave you to actually do this one yourself, because this one you have to pick your own. I've given you an example. That's the bell. I've given you an example of two numbers you can use, but your answers will change a little bit on this. So I'm just going to write out the points that I would use. And that would be 1988, where you have 35.7, and if we use 1996, where we have 33.1. Now you could choose other options. You could use 1992, where we have 42%, and 2012, where there's 40.9. There's plenty of options here. These two would actually give you where you're moving forward in time, but our number is actually decreasing. So that one works as well. You can do those, but I do expect you to actually try doing the average rate of change for these on your own. You can do it the same way as I used the numbers in part A. So if you need to pause, rewind, and watch through that part again, you can do that part again. I'm going to move on to our challenge problem, or our review problems. These are actually review problems. Neither of these are challenge problems, so we're going to cross out where it says challenge. These are review. Jada walks to school. The function d gives her distance from school as a function of time in minutes since she left home. What does d of 10 equals 0 represent in this situation? So it's giving her distance from school, so that's our output. And then it's a function of time in minutes since she left home, which is our input. So the input is 10 in this situation, right? This was our input. And that gave us an output value of 0. So this means she left from home, walked for 10 minutes, and at 10 minutes, she was then at school because she is 0 meters from school. So this means Jada reached her school at, or we can say after, I'm going to say after walking for 10 minutes. Now, we're still talking about Jada walking to school, and D is her distance from school, and T is the minutes since she leaves home. But now we're going to identify which equation tells us Jada is 600 meters from school after 5 minutes. So 5 minutes, that should be our input, and the 600 meters should be the output. So that is going to give us this answer here for A. So D of 5 equals 600. And that is it for this assignment. There was only 6 questions, so that is Unit 4, Lesson 7 of Illustrative Math Algebra 1.